In this section, we look at naming binary compounds. That would be compounds that consist of only two parts. We mainly focus on two different systems of naming compounds. The first system is called the prefix system. Easy to use. You're familiar with some examples of these compounds. However, it only works for molecular compounds, binary molecular compounds. So compounds that contain covalent bonds and are made up of just two elements. We'll also look at the stock system of naming, which is used primarily for ionic compounds, but it actually can be adapted to molecular compounds also. The prefix system, which again works only for naming molecular compounds, consists of the names of the two elements. There are prefixes added to the names of the two elements though. Whenever you have more than one of the first element, we use a prefix that tells us how many of that element there are. For the second element, we always use a prefix. And lastly, the ending of the elements is changed to "ide." This is the list of the prefixes that are used for the first 10 numbers. They are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. As I mentioned earlier, the second element in the name, we always change the ending to "ide." There are two exceptions, because usually we just take off the last syllable and make the last syllable "ide." But for two elements, oxygen and nitrogen, we do a little bit more than that. Oxide would sound a little bit awkward, so we actually remove the Y also and turn it into oxide. Likewise, with nitrogen, we don't just take off the last syllable and make it nitroide. We drop the O also to make it nitride. When we add the prefix to these elements, there's one other change that takes place with oxygen. Any prefix that ends in O or A, we drop the O or A before adding it on. So monoxide becomes monoxide. Di, no change, dioxide, trioxide, tetroxide, pentoxide, and so forth. Familiar example, carbon monoxide, CO. We do not use a prefix on the first element because there is only one of it. So it just reads carbon. Second element has to have a prefix. Since there's only one of it, it becomes mono or monoxide, carbon monoxide. Most of us are also familiar with CO2. Using the prefix system, we have C, no subscript, so there's only one of it, so it becomes carbon. Second element, there's two atoms of oxygen, so we use the prefix di and it becomes dioxide or carbon dioxide. The first example up here, N2O, we have to use a prefix on nitrogen because there's more than one of it. The prefix for 2 is di, so it becomes dinitrogen. Second element, oxygen, has to have a prefix. There's only one of it though, so the prefix is mono and it becomes dinitrogen monoxide. In the second example, no prefix needed on the first element because you have only one of it. Second element though has to have a prefix, so this one becomes nitrogen monoxide. In the third example, it's NO2, no prefix on the first element because there's only one of it. We always need a prefix on the second element, but since it's 2 oxygen, it becomes dioxide. In the next example, 2 nitrogen must use a prefix, so it becomes dinitrogen. Oxygen, there's 3 of it this time, so the prefix for 3 is tri and it becomes trioxide. For the next example, nitrogen, 2 of it. First element only gets a prefix if you have more than one. So again, the prefix di is used for dinitrogen. For the second element, the oxygen, there are 4 of it. The prefix is tetra, drop the A because you're adding it to oxygen, and it becomes tetroxide. And in the last one, dinitrogen, because you have more than one nitrogen. And for the second element, there's 5 oxygens. We use penta, drop the A, and it becomes pentoxide. Now we'll do a few more examples on the next slide, beginning with SO3. The compound name, sulfur. There's only one of it, so there's no prefix. For oxygen, there is a prefix. The prefix for 3 is used, and we get trioxide. In this one, I have iodine. There's only one of it, so it's just iodine. For the chlorine, there are 3 chlorines, so it becomes trichloride. For PBr5, one of the first element, no prefix, phosphorus. And Br, there's 5, so pentabromide. Reversing it now, we're given the name, we're asked to find the formula. For the first one, carbon tetraiodide, no prefix on carbon, so there's only one of it. Tetraiodide is based on iodine, and the tetra means there's 4 of it. For the next example, phosphorus trichloride, 1 phosphorus because there's no prefix. For chlorine, trichloride means 3. Dinitrogen trioxide, dinitrogen means N2. Trioxide, O3, and we're done. For the last example, tetraphosphorus, P4, decoxide, O10. Now, for the prefix system of naming, we have to be dealing with a molecular compound. The easiest way to tell if it's a molecular compound is to look at the elements that make it up. In all cases, if you have 2 nonmetals, it's going to be a molecular compound. There are some cases of metals combining with nonmetals to make molecular compounds, but those are rare. So those case-by-case basis, you can use electronegativities to decide what type of compound it is. But if you see nonmetals and only nonmetals, or a metalloid and a nonmetal, because metalloids have the same chemical properties as nonmetals, we treat it as a molecular compound and we can use the prefix system.